a quick reminder about object references and method calls. In this program that I have right now, what is taking place is that in my main method, so the main method executes. Try my best to do some writing. And when I think about the main method, I can think of two things. First of all, there's someplace compiled code. You know, I try to use some sketchy lines here which represent an executable code. On the other hand, when the main method is invoked, it gets its local scope of variables, right? It gets its stack frame. So the call takes place, and all this code gets access to this place in memory where the local variables are created. And so the scanner, the amount are all C format. These are all local variables. The double local variable is actually stored directly in the scope. But it is expected that any variable that refers to an object, such as number format or a scanner, which is getting instantiated by the new operator, in that case, you know, the scanner has to be constructed elsewhere by the new operator. This is my scanner in memory. And what happens is that my SC scanner is a reference to that object. So I'm actually dealing with indirect access to an object in memory through the reference. SC is the reference. It's not an object, it's a reference to an object. And the new operator, if I had it in place like I had it before, the new operator actually allocates this object in memory. This is what new does. It reserves the memory for an object and initializes it by calling the object constructor. And then it returns back a reference. In my case, what happened was that I never did this, so the scanner was intentionally set to null. And null is a legal keyword specifying, let's store in this reference a reference to no objects. Specifically indicate that yes, we have a reference. At some point we will create an object. We will most likely assign that object to that particular reference variable, but not just yet. And in this case, the next thing that happens, or soon enough, what happens is that I call another method. And that method is named, you know, get user input, right? So I abbreviate it. And it has its own compiled code, and it works with its own scope of local variables, right? Which is created for this method to execute during the method call. And so there I have, you know, the scanner, the reference to this non-existing, in my case, object is passed as a parameter, right? So it is passed as a parameter right here as an input parameter. And so I am thinking that maybe I am referring to some existing object, but in reality, this is null. So it just stores all zeros as the address internally, and it doesn't do anything good. Java Virtual Machine quickly detects that this reference does not refer to anything real in memory, and therefore it throws an exception. So another example in this output here is an example of a runtime exception. And we say that for all these varieties of different situations that could be taken at runtime, look, we have a variety of different exceptions. For example, if you're dealing with an array of integers, maybe, and your array of integers is like 5 elements, in size, but you're trying to access element number 10, then most likely you're going to get this exception. No such element, right? And we already saw today null pointer exception and input mismatch exception. Now those exceptions are all deriving from the exception object, which also exists in Java API. And we'll talk about this hierarchy in a little bit. We'll show how to create our own exception object. So those are interesting observations about our code. I'm moving on to the next slide. Example of the stack trace here. That's fine. So when we deal with exceptions, the situation is that some methods at some point may throw an exception. It could really depend on, on the situation. For instance, I could have a method here which takes one double and tries to divide it by another double. And occasionally, if the divider is set to 0, it will crash, right? The exception will be created for us, and so we'll be notified, and the program will stop, unless, of course, I handle that exception. So with that in mind, those methods here, the two methods on the scanner class can produce this input mismatch exception, and many other methods inside the scanner class, which we use to get user input at this stage of our programming exercises. They will be able to throw other exceptions, and other methods can be used. But that's the case. Integer parse int. Well, sometimes, again, let's demonstrate this. Just some example of code. If I say string, a string stir value, equals string 15.95, something like that. That looks like a dollar amount. And then, if I want to say double amount, double value, equals stir value. This, as you know, doesn't work. The types are incompatible, so what happens is that the string cannot be, by using just an equal sign, converted to a double value. But that's what my intent. Perhaps this string right here came from a file, or it may have come from the database, right? So it's completely legit for me to say, well, I have the string, but I want to convert it to a double value. How do I do this? There is this helper class named double. And it comes with a whole bunch of static methods. One of them is parse double, and you essentially pass the string value to it, and it will try to parse that string character by character and find out if there is indeed something that looks like a number which can be interpreted as real number. It will happily convert that number for us into a double format. So this particular one may throw an exception again if there's an unexpected situation. For example, if if there's bad format, but the different type of exception will be thrown. So again, if we want to bulletproof this line and make sure that it doesn't crash depending what the input is, then we need to use another try and catch, right? So it's very simple. Try this, right? Right here. If And in case if it doesn't work, then you can catch an exception, right? You can catch an exception. What exception is it? Let me look it up. Number format exception, right? So number format exception. And this is a real object. And you obtain access to this object in this catch uh, uh, clause of the try and catch statement. And you can give it a name. EX may be a name for exception that you never use. But that exception object does contain information about the stack. The stack trace is available there. The name of the exception is available. And this is what you do. You can just say, again, I have this issue with declaration this time. So I have to basically declare it earlier on, right? And so then try to initialize it doing this. But in case if I got an exception, I don't know. I may do something else. Okay, so I don't know how good this code is, but just to demonstrate it, in one spot I used one exception type to catch. In this spot I used a different exception. The number format exception is different from input mismatch exception. So, okay, but this is how you deal with exceptions in your client code. And the client code, we say the client code is the code that is trying to use existing objects or existing methods. We make calls, we try to interpret results, but if something goes wrong, we can always handle exceptional situations with try and catch.